Hello, teacher. It's our assignment 2, and in this task, our task is creating Python code that calculates how genus and the traits are passed within a family. The program shows the probability that a person has 0, 1, or 2 copies of gene and whether they express a specific trait. And the first, the program used a dictionary called probis, which stores all required probabilities, and it contains probabilities for genus, probabilities for traits depending on gene count, and the mutation probability. Mutation is the chance that a gene randomly changes when passed from a parent to a child. Our program starts with function main. We first load family data from our CSV file using the load data function, and this function reads the person's name, his parents, and the trait information. If the trait is unknown, the value is none. After loading the data, the program creates a dictionary with name called probabilities, and next our function is the load data function, and this function the program and creates a dictionary called probabilities, and it stores a probability distribution for each person having 0, 1, or 2 genes, and for expressing or not expressing the trait. And next our function is a power set. This function creates all possible subsets of people so that every scenario can be tested. If a combination contradicts known trait information, it's skipped. After that, our function is a joint probability function. Then the program iterates through all possibilities of gene distribution, who has 1 gene or who has 2 genes. For each combination, it calculates probability using joint probability function. And this function, key function in the program, it calculates the probability that events occur or not. And first, the program determines how many genes each person has, 0, 1, or 2. And if a person has no parents listed, then genus probability is taken directly from probis. And if parents are unknown, the program calculates the probability that each parent passes the gene to the child, considering possible mutation. Then the program calculates the probability of expressing the trait for each person. The gene probability and the trait probability are multiplied, and giving the joint probability for the entire family. After that, the update function is called. It adds the calculated joint probability to the accumulated values in the probabilities dictionary for each person. And the last one is normalize. It divides all values from their total sum, so that the probabilities for each person add up to 1. And this function ensures we have a valid probability distribution. And finally, the program prints the result, and we can see probability of each person having 0, 1, or 2 genes, and whether they express a trait or not. And in conclusion, the program uses a Bayesian network, tests all possible combination of genes and traits, calculates probability, updates distribution, and normalize the result. And you can see there are our results. If our first person is a Harry, and you can see probabilities of that Harry have 2 gene, 1 gene, and 0 gene. Yes, and you can see trait true or false for Harry. It's a second family, and this is third family. Next, our task is a task 2, where we try to find our flight will be cancelled or not, and we use the flight sample for our to create the agent. And we get our data set. After that, we will fill all of the non cells in our data set, and first, inside the main function, the program calls input delays function. The purpose of input delays function is to collect input data from the user, and in this function, the user enters delay values such as carrier delay, weather, or traffic delay, security delay, and the late aircraft delay. And after collecting the data, the main function sends these delay values to evidence from delays function. And the main responsibility of the evidence from delay function is to transform numerical delay values into evidence that can be understood by the probabilistic model inside the function, another function called categorized delay. And the categorized delay function value will take a value threshold low, threshold high function, analyze the number of delay minutes, and assigns risk level. And we have our predict cancelled function. It takes the evidence, and this uses a knife Bayes to calculate the probability. And it's a predict cancelled function, and after that it's our inputs to check the our AI agent. And there you can see we primarily use the delay rows in our dataset, and I changed the delays minute to get some results. And when we give some example like this, and our weather hike will be 1, and the NAS media is 1, and the carrier media is 1, it states that our high risk logic, it will be true, and the probability will be like this, and our agent prediction will be cancelled. Second one is an example of non-cancelled. It's it delays. I will give some lower inputs to do is this example to be not cancelled, and you can see our high risk logic will be false, and our probability lower than this, and our again prediction will be not cancelled.